Welcome to the Deep Dive. We're the show that tries to, unravel complex ideas and really get straight to the heart of them.
That's the goal.
And today, we're embarking on, well, the ultimate quest in physics, really. The search for a theory of everything.
The big one.
Exactly. And this isn't just about unifying forces like gravity and quantum mechanics, important as that is.
No, it goes much deeper. It's about understanding the actual fabric of reality itself, what it's truly made of, how it operates.
And maybe the most profound bit, where does something like consciousness fit into that picture, if at all?
Precisely. So our mission today in this deep dive is to explore 4 really ambitious frameworks. Each one offers a radically different blueprint for what fundamental reality might actually look like.
Okay.
We'll unpack their core ideas, their vision of what reality is made of, how they handle space and time.
Which is always a big one.
Always. And crucially, how or even if they make room for something as, well, fundamental to us as consciousness.
What an incredible lineup we've got.
Yeah.
Each one sounds pretty mind-bending just for the names.
They are.
So the contenders are relational quantum dynamics. RQD, which you mentioned, is combined with something called Holoinformational Monism.
That's right. RQD plus heck.
Okay. Then we have string theory, and you mentioned its holographic principle, which sounds fascinating. Then loop quantum gravity, RQG.
Yep.
And finally, causal set theory, or CST. It's a really diverse field. Let's start with RQD. It sounds like maybe the boldest newcomer. What's the core idea there?
Let's jump in. So RQD plus Holoinformational Monism. It basically proposes that reality's fundamental fabric isn't particles or fields, not in the way we usually think about them.
Okay, so what is it then?
It's information.
Yeah.
And relationships, interactions between systems, that's the bedrock.
Information as the bedrock.
And here's the really radical part. It posits something like a universal awareness as the ontological ground, the basis of being.
Universal awareness. Whoa. So consciousness isn't just something that, pops out of complex brains?
Exactly. In this view, it's not just something brains do. It's potentially the fundamental basis from which all reality actually springs. It's built right into the core ontology.
That is a monumental claim. Where does an idea like that even come from? What's the inspiration? It feels like it's drawing from some pretty deep wells, maybe physics and philosophy.
It's a fascinating mix, you're right. One key inspiration is Carlo Rovelli's work on relational quantum mechanics, or RQM.
Ah, Rovelli. Okay.
Yeah. Rovelli argues that quantum states aren't absolute properties of a system sitting out there alone. They're always relative information between systems.
Relative information.
He says there's no observer-independent state of the world, no sort of view from nowhere. Every fact, every property is relative to some other system.
And that connects to the observer problem in quantum mechanics.
Directly. This relational view inherently tackles some of those tricky paradoxes because it says the state depends on who's asking, or rather, what system is interacting.
So it's all about the relationships, the interactions, not independent things out there with fixed properties.
Yeah. Precisely.
That sounds a bit like John Wheeler's famous it from bit idea. Is that connected?
Absolutely. Wheeler's it from bit is foundational here. The idea that physical reality, the it, emerges from informational distinctions, the bit.
The participatory universe.
Yeah.
Where observation or interaction is key.
Exactly. And then for the consciousness part, RQD draws heavily from Giulio Tononi and Christoph Koch's integrated information theory.
IIT.
Right.
IIT, I've heard of that. It tries to quantify consciousness.
Kind of. It posits that consciousness is integrated information. There's a mathematical measure called phi, symbolized by A.
Phi?
Yeah, phi. It roughly measures how much information a system generates as a whole beyond its parts, how irreducible it is.
Okay.
RQD takes this idea and suggests that consciousness is the intrinsic, the first-person experience of a system's extrinsic, measurable, causal information structure. It's the what it feels like side of that integrated information.
Wow. Okay, so let's break down the key ontological moves then. What does this actually mean for reality? Starting with space and time, are they fundamental?
Not at all. In RQD, there's no pre-existing space-time container.
No stage for reality to play out on.
Nope. Space-time itself is seen as emergent. It arises from this network of quantum interactions and information flows.
How does that work? How does space emerge?
Well, think about entanglement. Quantum entanglement. In RQD, entanglement can actually define spatial connectivity. The more entangled two systems are, the closer they are effectively, regardless of apparent separation in some background space. It's as if space is woven from these connections.
So entanglement isn't just spooky action at a distance, it is the distance or lack thereof.
In a sense, yes, and time is similar. It's also emergent, maybe something like the thermal time hypothesis, where time flow relates to thermodynamic change and entropy within the system, not some universal clock ticking away.
That's completely different from how we experience things. Space and time feels so absolute, so fixed.
Our classical intuition, exactly.
And then there's this idea of perspectival facts. Doesn't that cause problems? If there's no single objective truth, just different perspectives, how can science even work?
That's a really crucial question. RQD argues there's no single God's eye view. Each observer or observing system has its own valid state description for another system.
And these descriptions don't have to agree.
They don't necessarily have to be unified from some hypothetical outside viewpoint that doesn't exist within the system. RQD says both perspectives can be correct relative to the observer.
Okay.
Think of it like looking at a complex sculpture from different angles. Each view is valid, shows real features, but no single view captures everything all at once. This directly addresses paradoxes like Wigner's friend.
Wigner's friend, where observers seem to get contradictory results for a quantum measurement. RQD says both results are true relative to their own perspective.
Essentially, yes. Quantum facts are relational.
So what about the observer themselves? Are they special? Outside the system somehow?
No, that's another key point. The observer is integrated into the physics. There's no sharp observer system cut.
So no ghost in the machine.
Right. An observer is just another physical system, but one with a very high degree of integrated information, a high AIMP value. Conscious brains are like complex nodes in this universal quantum network, and their high 8 corresponds to a unified point of view, their subjective experience.
The integrated information is the experience.
That's the proposal.
Which brings us back to that really profound claim you started with. Universal awareness as ground. How does that fit with the whole network idea?
It suggests that this entire relational quantum network, this web of information and interaction, might itself be pervaded by a kind of universal awareness, that this awareness is the intrinsic aspect of the information field itself.
The reality is fundamentally mental or experiential.
That's the direction it points. It's a kind of idealism, but grounded in modern physics concepts. It aligns with a philosophical stance called ontic structural realism.
Ontic structural realism.
Yeah, the idea that fundamental reality isn't made of individual things or objects, but rather the structure of relationships and patterns between them. In RQD, everything is just patterns within this one substance information.
Which elegantly avoids the old mind-body problem, the Cartesian split.
Exactly. It tries to build a monism, a single substance reality where mind and matter are just two aspects of information, solving that dualism by construction.
Okay, RQD plus him is a lot to take in. It really prioritizes information, relationships, and consciousness.
It's a very different starting point.
Definitely. So how do the more, let's say, established frameworks tackle these same huge questions? Let's turn to string theory first. What does it say is the ultimate ingredient of the universe?
String theory takes a more, perhaps traditional approach in some ways. It replaces the idea of point-like particles, electrons, quarks, etc. with tiny, vibrating, one-dimensional strings.
Like little violin strings.
Sort of, yeah. And the different ways these strings vibrate, their different notes, manifest as the different particles and forces we see, including gravity, which is a big plus. It naturally incorporates a quantum theory of gravity.
So its fundamental reality is still object-based, just extended objects, strings instead of points?
Yes, its ontology is firmly realist and object-based. Strings are the fundamental entities.
And space-time.
It generally assumes an existing space-time for the strings to vibrate in, though it's usually a much higher dimensional space-time, like 10 or 11 dimensions, initially fixed.
And it also has brains, right? Higher dimensional things.
That's right, brains like membranes, which strings can end on or move along. But what's really fascinating, and maybe where it connects a bit with RQD's information focus, is the holographic principle.
Ah, yes. The universe is a hologram idea that always captures the imagination. Tell us more about that.
The holographic principle came out of black hole thermodynamics. It suggests, quite counterintuitively, that all the information needed to describe a volume of space can be encoded on the surface area bounding that volume, not the volume itself.
Like a 3D image stored on a 2D film.
Exactly like that. It implies reality might be fundamentally lower dimensional than it appears. There's a concrete mathematical example called the AD-SCFT correspondence.
AD-SCFT.
Right. It shows a precise equivalence between a theory of gravity and a certain kind of space-time, anti-de Sitter space, or ADS, and a quantum field theory, conformal field theory, or CFT, living on the boundary of that space.
So space-time geometry. Gravity, emerging from quantum information on a boundary.
Precisely. It's a powerful link between gravity, quantum theory, and information. It suggests spacetime might be emergent in string theory too, in a way.
How does string theory handle the observer? Does consciousness play any role?
Typically, no. Observers are usually treated classically as external measuring devices or just complex physical subsystems within the overall reality described by the strings. There's no intrinsic role for the act of measurement or consciousness itself.
And its overall metaphysical stance.
It's usually seen as physical monism. Everything boils down to strings and their interactions, but it faces a big challenge. The landscape problem.
The landscape, meaning too many possibilities.
Exactly. String theory seems to allow for a vast number, maybe 10 to the 500 or even more, possible vacuum states, each corresponding to a different universe with potentially different laws of physics.
Which makes it hard to predict our specific universe.
Very hard. It raises questions about predictivity or perhaps implies a multiverse where all these possibilities are realized somewhere.
Okay, so that's string theory. Next up, loop quantum gravity, LQG. How does it differ? You said it takes a very different approach.
Completely different starting point. LQG doesn't start with matter, like strings, and try to get gravity. It starts with Einstein's theory of gravity, general relativity, and tries to quantize spacetime itself.
Quantized spacetime, meaning space and time aren't smooth.
Exactly. LQG proposes that spacetime, at the incredibly small Planck scale, is actually discrete. It's made of fundamental atoms of geometry.
Atoms of space.
You can think of it that way. These are represented mathematically as nodes and links in something called a spin network. So space is granular, fundamentally chunky.
And the ontology here, is it objects, again, like little space atoms?
It's physical, but also deeply relational. Space isn't a container these atoms sit in. The spin network, the web of relations between these quantum degrees of freedom, is space.
So the relationships create the space, they don't happen within it.
Precisely. And crucially, this makes LQG background independent. There's no fixed stage, no pre-existing space-time geometry. The geometry itself is dynamic and quantum mechanical.
And does this help with things like singularities and black holes?
It's hoped so. LQG predicts that quantities like area and volume are also quantized. They come in discrete chunks. There's a smallest possible non-zero area, a smallest possible non-zero volume. This granularity might prevent the infinite density of classical singularities.
Does LQG have anything to say about observers or consciousness?
Nope. Like string theory, LQG is a purely physical theory focused on quantizing geometry and gravity. Observers and consciousness don't feature fundamentally in the framework itself.
Okay, one more contender. Causal Set Theory, CST. What's the picture here?
CST takes yet another route. It suggests that the fundamental reality isn't space or strings or even geometry, but causality.
Causality itself.
Yes. It's the length scale. The universe is proposed to be a discrete set of elementary events. And the only fundamental structure is the causal relationship between these events, a partial order saying which events must precede others. Event X comes before event Y.
So reality is just a pattern of before and after, a network of causal links.
Exactly. It's an incredibly sparse, minimalist ontology, event-based monism. Reality is just this abstract pattern of causal arrows.
Where do space and time come from, then?
Time, in the sense of this causal order, is fundamental. Space is derived, emergent from the density and pattern of these causal connections in the network. A large number of these discrete events, appropriately linked, approximates a smooth space-time manifold at macroscopic scales.
So time is fundamental, space is emergent. That's interesting.
And some CST models even have a growth dynamic. The causal set literally grows one event at a time, adding to the present. This suggests an intrinsic becoming, an objective flow of time built into the universe's structure.
A universe that's constantly coming into being.
Potentially, yes. It's a very elegant, parsimonious idea.
And the observer in CST, any role for mind?
Again, no. Like string theory and LQG, CST omits any fundamental role for observers or consciousness. It describes an objective causal web, growing or fixed, independent of any mind experiencing it.
Okay, we've laid out the four main players. Now let's really get into the comparison. The metaphysical differences. Where are the biggest gaps and maybe surprising bridges? Let's start with that idea of ontological monism, what each theory says reality is one thing of.
This is where you see a really stark contrast, especially with RQD. RQD plus him proposes what's called dual aspect monism. There's only one fundamental substance information, but it has two aspects. an extrinsic, physical aspect, what we measure, and an intrinsic mental aspect, what it feels like, consciousness.
So it tries to solve the mind-body problem right there by saying they're two sides of the same coin.
Exactly. It aims to solve it by construction. It's arguably the strongest claim to monism because it integrates mind.
How do the others compare on that front?
String theory is typically a physical monism, everything is strings. But, as we said, it might imply a pluralism of possible worlds or universes due to the landscape problem, and no fundamental role for mind.
Right.
LQG is aiming for a monism of quantum geometry, but currently it still kind of has to assume matter fields exist separately alongside the geometry, so it's not quite fully unified yet. And again, no fundamental mind.
And CST.
CST is perhaps the most purely monistic in a physical sense. Reality is just causal events in their order, extremely parsimonious, but again, no fundamental mind.
So the huge philosophical difference is really RQD attempting to weave mind and matter together from the ground up, while the others focus purely on the physical.
That's the core distinction, yes. It raises that deep question. Can a theory of everything be considered complete if it leaves out conscious experience, which is arguably the most immediate reality we know? Is that a feature to be explained later or part of the foundation? RQD bets on the latter.
A huge point indeed. What about the contrast between relational versus absolute structures, especially regarding observer dependence? RQD sounds radical here.
It is. RQD embraces a radical perspectivalism. No single, absolute, objective state of affairs. Only relative facts, defined by interactions between systems or observers. It's a network of perspectives.
While string theory aims for a single, objective reality, even with things like holography.
Yes, string theory generally seeks an objective description. Holography offers dual descriptions, but they're considered mathematically equivalent ways of describing the same underlying objective reality. Observers are just complex subsystems within that reality.
And LQG.
And CST.
LQG is relational, concerning space-time itself. It's background-independent. Geometry emerges from relations. But it isn't explicitly perspectival about quantum states in the way RQM or RQD is. And CST describes a single objective causal set, observer-independent.
So RQD's stance on relationalism is a potential solution to quantum weirdness like measurement paradoxes.
That's the claim. By making states relative, it dissolves paradoxes that arise from assuming a single objective state that everyone must agree on. Other theories often have to invoke interpretations like many worlds, implicitly or explicitly, to deal with those same issues.
Let's talk space and time again. We touched on emergence. Is there a consensus forming there? There's a remarkable convergence, actually. RQD, LQG, and modern string theory, especially through holography, all strongly suggest that space-time is not fundamental, it's emergent.
It's not the bedrock. It's built out of something deeper.
Exactly. And CST agrees, positing space-time emerges from its discrete causal order. So the idea of emergent space-time seems to be a common thread across these very different approaches. That's huge.
But they diverge on how it emerges or what's fundamental underneath.
Right. The divergence is fascinating. RQD suggests time and space emerge from information flows, entanglement, maybe even allowing for indefinite causal order where before and after aren't always fixed at the deepest level.
Which is mind-bending.
Completely. Whereas CST makes time, that causal order, absolutely fundamental. Everything else emerges from it. So the big question remains, is causality itself fundamental? Or is it too emergent from something like information or entanglement?
Wow, okay. And what about the role of information itself? That seems to pop up everywhere.
It really does seem to be a unifying theme, doesn't it? For RQD plus him, obviously, information is the fundamental substance. It's front and center.
And in string theory.
Information is crucial, especially with holography. Concepts like the Bekenstein bound limiting information in a volume or AD-SCFT showing geometry emerging from quantum entanglement information on a boundary. It points strongly towards information being primary.
So that aligns surprisingly well with RQD's premise, even if the starting points are different.
It does. And even in LQG and CST, while they might not explicitly talk about information as the base substance, their fundamental structures, spin networks, causal sets, are inherently informational. You count their states for entropy, they're essentially data structures representing geometry or causality.
So there's this broad trend in fundamental physics pointing towards information being key. RQD is maybe just the most explicit philosophical articulation of that trend.
You could certainly see it that way, yes. It takes that trend and runs with it, making information the ontological primitive.
Let's revisit consciousness one last time then. We know the divide is stark, but just to summarize the gap.
The chasm is huge. String theory, LQG, CST, They are essentially silent on consciousness in their fundamental equations. It's either considered an emergent phenomenon to be explained by higher-level science, maybe neuroscience, or it's simply deemed outside the scope of fundamental physics.
But RQD plus him says you can't leave it out.
Precisely. It argues consciousness is a fundamental aspect of reality itself, intrinsically linked to information. It aims to dissolve the hard problem of consciousness by saying experience is what information is from the inside. It's not an extra ingredient, it's the intrinsic nature of the informational structure.
So these theories offer profoundly different views of reality. How on earth could we actually know which one, if any, is closer to the truth? What's the empirical outlook? Can we test these ideas?
That's the billion-dollar question, isn't it? For RQD plus Holoinformational Monism, testing is tricky, but not impossible. One area is looking closely at quantum observation paradoxes.
Like Wigger's friend again.
Exactly. If experiments, maybe using complex entangled quantum systems as observers, confirm that standard quantum mechanics remains consistent even in these weird scenarios, that would bolster RQD's relational perspectival view. If we found evidence for objective collapse, the wave function collapsing on its own, independent of observers, that would undermine it.
What about the integrated information part? Can we test if high-I systems behave differently?
That's incredibly difficult. RQB doesn't necessarily claim consciousness causes collapse in a simple way, but that it's the intrinsic side of the information. Maybe future experiments could probe if the complexity of informational integration in a system affects quantum phenomena in subtle ways. It's very speculative.
And emergent spacetime.
There are actually tabletop experiments being designed now, like proposals by Bose, Marletto, Vedral, to test if gravity itself can create entanglement between two nearby masses. If they succeed, it would be huge support for gravity being quantum and potentially for spacetime emerging from entanglement key ideas in RQD.
Okay, what about string theory? What empirical signs should we look for?
The classic hopes are discovering supersymmetry, a predicted symmetry between matter and force particles, or evidence of extraspatial dimensions at particle colliders like the LHC. Neither has shown up yet, which is a bit worrying for some versions of string theory.
Any other avenues?
Cosmologically, maybe detecting cosmic strings left over from the early universe, or specific patterns in the cosmic microwave background radiation or gravitational waves predicted by string-inspired inflation models. And progress on the theoretical side, like using the holographic principle, add ECFT, to model real-world systems like quark-gluon plasma, or resolving the black hole information paradox in a way consistent with string theory also builds confidence.
Right, and loop quantum gravity, what are its potential signatures?
LQG's prediction of discrete space-time is key. One possible, though tiny, effect could be a violation of Lorentz invariance. Meaning the speed of light might not be perfectly constant for all energies. Very high-energy photons arriving from distant cosmic events might travel at infinitesimally different speeds depending on their energy. Telescopes like Fermi are looking for this.
Any others for LQG?
Perhaps unique signals in gravitational waves, maybe from merging black holes showing quantum effects near the singularity, or even evidence of black hole bounces instead of singularities, where quantum gravity pressure halts the collapse. Any direct evidence of space-time granularity would be a massive win for LQG and also CST.
Speaking of CST, what could hint at causal set theory being right?
One intriguing prediction from some CST models is that the cosmological constant, the thing driving the universe's accelerated expansion, might not be perfectly constant, but could fluctuate slightly over cosmic time due to the random growth of the causal set. Detecting such a variation would be huge.
Anything else?
Also, the fundamental discreteness might lead to a kind of inherent jitter or noise in the position of objects at the Planck scale, which might, in principle, be detectable in ultra-precise measurements someday. And finding evidence for that growth dynamic, that objective becoming, would be truly revolutionary.
It really seems like finding one smoking gun for any single theory is unlikely soon. It's more about chipping away, finding evidence for aspects like space-time emergence, or the role of information.
Exactly. And you mentioned quantum computing earlier. That could be a game changer.
How so?
By allowing us to simulate these incredibly complex quantum gravity scenarios, we might be able to experiment on these theories inside a quantum computer, testing their consistency and predictions in ways we can't do physically yet. It blurs the line between theory and experiment.
We've covered so much ground today diving into this ultimate quest. When you step back, what's the main takeaway for you from exploring these different paths to a theory of everything?
For me, it really highlights that this quest is as much philosophical as it is scientific. Each theory forces us to confront fundamental assumptions about reality. What's real? What's emergent? What's the role of the observer, of information, of mind?
And RQD plus him really stands out in how it tackles those assumptions head on.
It does. It's unique in suggesting that maybe solving the deep problems within physics, like quantum measurement, and solving the deep problem of consciousness's place in nature, are maybe not separate problems. Maybe they're two sides of the same coin. It explicitly tries to address the blind spots. Others leave open the mind-matter gap, why this universe exists, how observers fit in. It's a bold move.
It makes you wonder if the final theory might end up being a synthesis, borrowing ideas from several of these.
It's definitely possible. You could imagine perhaps some future theory that looks like a holographic version of LQG, where discrete spacetime emerges from entanglement information in a way that's consistent with string theoretic principles and incorporates the observer's perspective a la RQD. That would be quite something.
Truly breathtaking. It really feels like the ultimate answer might be, as the saying goes, not just stranger than we imagine, but stranger than we can imagine.
It might well be. It could require a complete paradigm shift, perhaps the kind RQD is hinting at, or maybe the answer will turn out to be a more conservative extension of current physics, and consciousness will remain something explained emergently without changing the fundamental laws. We just don't know yet.
But this whole conversation, this deep dive into the possibilities, is so valuable, isn't it? It pushes us towards a more holistic view, trying to weave together the physical, the bit, information, and maybe even the mind into one coherent story.
Absolutely. It's the ongoing quest to understand reality in its fullest possible sense, constantly pushing the boundaries of our knowledge and imagination. It reminds you just how much we still have to learn.
What a fascinating journey it is. Thanks for exploring it with us today.
My pleasure. It's endlessly fascinating territory.